I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Gavin White, co-founder and CEO About Energy. On today's episode, we'll explore how deep cell level testing, large-scale battery data, and simulation tools are changing how engineers optimize battery performance. We hope you enjoy this episode. Gavin, welcome to the podcast.
Thank you very much. It's great to be on the show. Thanks, Grayson.
It's great to have you here. Batteries to me, are fascinating. They're complex. I don't understand a lot about them. I mean, you have a PhD where you studied simulation and modeling of thermal properties of batteries. What was the inspiration for that? And for me, the curiosity, what's the big takeaway that I can learn from your PhD?
Yeah, well, maybe we'll get onto it, but I was inspired to do a PhD in batteries because I did the Formula Student Program, which I think you know is Formula SAE in the US. And in that, we were trying to build a battery electric car and we didn't have a clue what we were doing. And every time we'd get stuck, we'd ask the academics and nobody had answers on how batteries work. So that curiosity, I knew at that point Tesla was growing rapidly. Like it was quite clear electric vehicles were the future, but we had this huge skills gap as a society. So I wanted to do a PhD in batteries to understand that. And my PhD was sponsored by Rolls-Royce Aerospace, and they were looking at large battery packs for airplanes. So it was in that PhD that I sort of dived into, well, what's the problems associated with batteries? And that was the genesis of where About Energy came from.
That's wonderful. The electric car, did you ever get it to work? Did you ever get over the hump and get it to work those early years?
Yeah. Well, we were at the concept stage, so the answer to that is no. It's still, I think Formula Student teams still find it very, very difficult. The regulations to actually get the car to track is so difficult. But yeah, we were at the concept stage even back then. It was still very new, even when I was doing Formula Student.
Wow, was that were you going just trying to figure out how to get the vehicle to work, or just how early was it in that concept stage?
Yeah, so our team had always made a combustion car for like the last 20 years, and we'd been very successful coming like 7th, 9th in the UK competitions. But the university wanted to shift to electric to try and get the students to develop more skills for that industry. So I was the very first year we were trying to build an electric Formula Student car. And you can imagine just how difficult that is across the batteries, the motors, the inverters. So it was very much concept stage at that point. And I think even now the team, only in the last year or two, so 5-6 years later, have had a car that they've been able to run at the competition.
Was it that competition, the Formula program, that you started to get the nuggets or the ideas in your head? Wait a second, maybe I should build a company. And oh, by the way, I'm going to call it About Energy because I'm thinking about this.
Yeah, well, that was really the genesis of especially how I got interested in batteries. As an engineer, I just love fixing things and understanding how things work. And even now, there's nothing in the world more complex to me than a battery. I still have such a limited understanding of how they work. So for me, that's the most exciting thing. Like every day is a learning day when you're working in the battery industry.
Batteries are complex, and your company About Energy, you offer deep insight into batteries for your customers. How are you doing? Because you say you're learning. I agree with that. There's a lot to unpack, but what are those deep insights that you're offering for your customers?
Yeah, well, the biggest one is really around model-based design. So when I was at university, and I also worked at Aston Martin, the car company, for about a year and a half, everything in the automotive industry is model-based design. So you probably know it yourself when it comes to aerodynamics, suspension, strength of materials. We use simulation to basically save all the prototyping we used to do 30, 40 years ago in the real world. So we use model-based design to iterate the designs thousands of times to converge in a solution. And then at the end, you build a validation prototype to check that your simulation model was accurate. And in the world of strength of materials, suspension, they're very accurate now. Even aerodynamics are very accurate. So then I moved into the world of batteries. My PhD was sponsored by Rolls-Royce. They had these huge battery packs for airplanes, and they're a massive proponent of model-based design. So they're building these simulation models of their battery packs. But when they would do experiments and then build a simulation model, the errors were like 50%. So effectively, the models just weren't even close to representing the real world. And that's when model-based design breaks down. Yeah, you can't do model-based design if your model's not accurate. And what I've seen at Rolls-Royce and at other companies, pretty much every customer we speak to, is people do a lot of battery development empirically. Like it's actually crazy how much of battery development is still done through trial and error, build things and see what works. So coming back to your question, what we do is we make really accurate simulation models and we enable our customers to do model-based design. And the benefits for that are, you can imagine, reduced time to market and reduce cost. Like you don't have to build things in real life anymore. You can just simulate them.
You've publicly stated that your data can cut battery development time by 70%. So I have to ask, what's the secret sauce in the simulation that's allowing your customers to achieve that remarkable breakthrough?
Yeah. So when it comes to simulation, you're probably familiar with the big engineering modeling suites from Siemens, Dassault Systems, Ansys, MATLAB Simulink, etc. So these simulation platforms, fundamentally, they just solve mathematics. They solve equations, often in a multi-physics domain. But all them equations and mathematics, they work on underlying properties, and parameters. So you can imagine in a strength of materials test, you need the materials properties like the Young's modulus, etc. And in the world of batteries, you need properties as well. You have all the parameters. So you have equivalent circuit models, thermal models, electrochemical, and they all have parameters. And then parameters are unbelievably difficult to measure or estimate. Yeah, they're often empirical parameters, so they're an estimation rather than a direct measurement. So that's what we do. We measure them parameters really accurately using a lot of secret in-house IP. About half of it's in the lab testing we do, and half of it's in the modeling. So that allows us to build these simulation models that other companies just aren't able to do. And that's how you save that 70% time, is because now you can actually design and develop your battery pack in a virtual world rather than having to go through all these physical prototypes. And that's saving, like for one of our customers, McMurtry Automotive, who make the world's fastest car, not just EV, but the world's fastest car. Yeah, they've been able to save 6 months of development time.
That's a tremendous amount of time. That even though automotive goes in 7-year cycles, six months is a tremendous amount of time. How long did it take you to develop that platform that's enabling this? Was it years and years of tinkering and prototyping? Got to start over. The code base isn't right. Okay, let's go rebuild. We can just better. Well, how long did that take, and what was that process like?
Yeah, well, this is where I have to be honest, Grace, on that. This is not all my invention, to be honest. So I was just a mere PhD student at Imperial College in London. And actually, a lot of the foundations for the company were developed over the preceding decade at both Imperial College, where I'm from, and also the University of Birmingham in the UK, where my co-founder's from. So a lot of this research has been done in academia for many years, and from the academics that helped co-found the company with us, we were able to bring a lot of that IP together. And effectively, myself and Kieran have been very fortunate enough to be just in the right place at the right time to take that IP and then bring that into a commercial setting. But yeah, many of the techniques that we have in the company were developed over many, many years at these institutions.
Let's zoom out for a moment, because if you look at the upper school in the UK, universities and colleges, some of the finest universities and colleges in the world, and we've seen all the stuff that's come out of Cambridge and Oxford. What is it in the water there that's allowing all this break? Because you have ARM there, you have Wave there, you have all this incredible technology that's being developed in the UK. So what's in the water in these university systems that's enabling it to happen?
Yeah, I think that's a great question. I think it's just the long-standing pedigree that attracts people there. Like at Imperial College, I was lucky enough, like the academics are just world leaders. They get attracted there because of academics preceding them. Like the department at Imperial College that I did my PhD in, just beneath us was the Aerospace engineering department. And that's where a lot of the CFD packages were actually invented. So like CFD actually originated in the same building that I did my PhD in. So I think that encourages people to go to these universities because you have great academics, and then it becomes a bit of a self-fulfilling prophecy, right? Then PhD students and become academics, stay at the universities. But yeah, we're so fortunate in the UK to have 3 of like the world's top, maybe the top 10 universities, and the technology that leads to.
Yeah, I mean, if you look at some of the most famous people, Sir Isaac Newton, for example, we can go down the list of, if you want to call them household names that have an incredible scientific pedigree. And staying on the scientific pedigree theme, your company recently just launched the Voltt, a database of commercial battery models. Talk about that platform, please.
Yeah, so the Voltt is really a tool targeting the challenge of cell selection. So when you're designing a battery pack, the biggest choice you have to make is what battery cell you're going to put in there. And you might not believe it, but there's about 1,000 different battery cells in the world you could pick from Samsung, LG, Panasonic, etc. Like, yeah, Samsung alone have over 40 cells that are the exact same geometric size, but just different variants of chemistry. And like many pack designers out there, the challenge is like, which one do I pick? And you're trying to optimize for, I need the performance that meets my design requirements at the lowest cost. And you're trying to find what cell out there meets that. And this is a huge challenge our customers face. At the moment, what they do is they request samples from these different manufacturers and they test them in their labs. And this takes, 6, 12 months. In reality, they can't test 1,000 different cells. They have to down select to just maybe 5 or 6. So they end up picking the suboptimal cell. It's a bit more expensive or doesn't have the performance they need. So that's a challenge we identified early on in the company. And what we set out to do was build a database of these commercial cells. And instead of getting a data sheet from a manufacturer, now we're going to have independent third-party verified data about energy is produced on all these different cells to enable companies to compare apples and apples and enable them to go through that process of cell selection.
And before that, is it safe to assume that there wasn't a database that they can reference? You have 1,000 cells to choose from. It's basically, okay, let's hope for the best.
Yeah, well, everybody had to go and compile their own database. Everybody has to go and ask Samsung and LG, what's your product portfolio? Go scrape data sheets, often from Reddit, where people have just shared them. Yeah, hugely time consuming. So we're centralizing that, creating a single source of truth for the battery industry. And at the start, it was hard fought. We had to go out and literally scrape data sheets from Reddit. Whereas now it's been recognized that this is a place people use for cell selection. And we've been able to strike partnerships with the manufacturers themselves. So the likes of like the high performance manufacturers like Amprius in the US, Molicel in Taiwan, BEI in the US as well. They now send us cells before they're publicly released so that we can add them to the database, which fundamentally is an advertising tool for them.
Well, it validates what you're building. Also, I mean, we have to look at that aspect of it. And you've tested over 500 cells in-house. And that's basically 50% of the market. What are some of the most interesting things that you've learned testing these cells?
Oh, well, God. Where do we start? A lot of very interesting things. Yeah, some manufacturers can be a little bit over-promising in what they deliver on the data sheet. I guess that's one big thing. But two is also just how simulation can be used to cut down on the time it takes to collect this data. So a very common test in the battery world is something called HPPC. So it's high pulse power characterization. So you basically just pulse the cell, and it takes about 3 months. You pulse the cell at lots of different temperatures, states of charge, to figure out how much power is available at all these. And you basically form this like a 3D surface plot of a map of how much power is available within the cell. And yeah, that does take like 3 months to run. Whereas what we've been able to do, I think one of the most exciting things now is now that we have simulation models, something that used to take 3 months in the lab, we can now do in the Voltt in literally 4 seconds. And now you can run that at different pulse lengths and different temperatures. So I think the most exciting thing for us has been to actually get data from batteries. You no longer have to do the testing. Once you've been able to build a model, you can actually get that through simulation. And that's unlocked whole new levels of optimization that's possible. So I think that's been our biggest learning. Even we didn't expect it to be as powerful as it's become for us.
No, that's a very wonderful thing. I've got to ask the curiosity question. So you mentioned some manufacturers overpromise, and you put this through the Voltt system, and it doesn't live up to the hype. How do you deal with the political implications of, I don't want to call you the truth detective, but to some degree you are the truth detective?
We have that. A few people have actually mentioned that to us, and some manufacturers get very nervous, and other ones get very sort of bullish on sending us their cells. So how we deal with it is that we are completely independent. The cell manufacturers don't pay us. We're never going to be paid by the cell manufacturers to collect this data. So we just publish the data as is from our lab, and ultimately, we're basically allowing people to get that truth, to that central source of truth for the battery industry. And the truth is what it is. There's no hiding that. And if some manufacturers don't like it, it just means because their product probably isn't good enough compared to the market. So I think we have an important role in not just the transparency, but also leveling up the market. Is no longer can a manufacturer sort of be subpar and get away with it. Like, they have to level up. They have to make good products if they're going to sell batteries. And I think ultimately that's, that is what the market requires.
It moves the market forward in, I'll say, a positive, transparent way, which could increase adoption. Do you make, if you want to call it the benchmarking data, do you make any of that benchmarking data public, or is that all behind a paywall?
No, so we have a high-level database, which is initially it's data scraped from manufacturer data sheets. But yeah, soon we'll be publishing our own data sheets where for a number of the cells in the database, we'll actually publish high-level data on every single one that will be public available and for free. And then obviously the more advanced, sophisticated models, that's going to be behind a paywall. But even at that, it's quite a low-cost subscription compared to the amount of time that it saves the company. But yeah, we do want to make as much of the data public as possible to just enable the industry.
How do you see the Voltt system being used? Is it going on the procurement side? Is it going on the engineering side? Is it going in various different elements of the organization? Where do you see it living inside an organization that batteries are critical to what they're building?
Yeah, it's like you say there, it actually sits within multiple different departments, and that activity of cell selection, as you say, it's used by procurement, it's used by the concept team, it's used by the pack team to come up with like pack concepts after they've sort of selected their cell. It's also actually used by the sales engineers, because the sales engineers for a pack design company, they need to sell battery packs and they need to be able to, answer a customer's RFI or RFQ very quickly. So being able to prototype that on the Voltt has been really useful for them. So yeah, what we find is it's often used between about 3 and 5 different departments within a company, the whole way from sales to procurement to engineering.
I mean, that's if you want to call it the corporate side, but let's go to the fun side. And engineering race cars. Are you seeing any teams trying to use this data to quote unquote get a competitive edge in a race, whether it's a sanctioned race or it's just for fun? Are you seeing the motorsports industry look to this data?
Yeah, for us, some of the motorsport teams are the most advanced. Like I was lucky enough when I worked at Aston Martin to work on something called the Valkyrie hypercar, which Aston Martin built with Red Bull Racing. So I got to go to Red Bull Racing, the Formula One site, and actually meet some of the Formula One engineers. Was in the same office as Adrian Newey, who's one of my hero mechanical engineers. And I got to see in Formula One, they're restricted in terms of how much real world testing they're allowed to do to try and keep a cap on the costs. So they do a lot of simulation, a lot of model based design. I remember going to see the Formula One simulator where they can actually drive the car in the simulator that's powered off of Simulink models. And they can then adjust the Simulink models, like the suspension parameters. And then the Formula One driver can give like real-time feedback. So Formula One take model-based design to the absolute extreme. And that's sort of true for a lot of the motorsport industry. So for us, they're perfect customers because they understand the value of model-based design. They do it in everything else, and they just struggle with it in batteries. But that's where our data and our simulation models really enables them. But yeah, they've been perfect early adopters because they understand the value of it.
Then how about if you go into the hypercars or the collectors, like that other aspect of the market? Then you have the amateur racers. Are they starting to look into that data as well?
A little bit, but not so much, because a lot of smaller amateur racers, anything electric, they're going to be buying in a battery pack from somebody else. So you've got big sort of tier 1 battery pack developers for motorsport applications like Fortescue Zero, who used to be Williams Advanced Engineering, and also Podium Technology. So there's a number of different companies around the world that make battery packs for motorsport applications. And often the end users, whether it's Extreme E or Formula E, often they're not the ones actually building the battery packs themselves.
That's interesting. So over time, how light do you think batteries will get?
But they're definitely going to get lighter. Every year they get better and better. It's, in semiconductors, we have Moore's law, which is every 2 years, they sort of double. It's not quite that good in batteries, but I think we're talking probably, from my analysis, it's like anywhere from 10 to 20% every year they get better, which is incremental year on year, but over a 5-10 year period, that adds up to be quite material. So I think realistically, we can expect in the next 10-15 years for battery packs to be like a half or a quarter of the size they are today. And it's not just about the raw energy stored, it's also about the integration and getting the most usable energy out of the battery pack that exists, and also the software that goes on top of that. Like, you've probably heard of things like fast charging, which traditionally damages and destroys a battery pack, but with clever software, you can actually prevent that from happening. So there's a lot of innovation, not just at the material level, there's innovation at the pack level and the software level that enables extra performance to be squeezed beyond just chemistry innovation.
Overall, is it just a combination of everything that's allowing these packs to get lighter, or what is it that's allowing that?
Yeah, it's really a combination of everything. There's not, from our perspective, we don't see like one core drivers. Obviously, the chemistry innovation is quite high, but the innovation at the pack design level, things like welds, bus bar connections, thermal management systems, and then at the software level, the BMS, fast charging, there's very significant innovation in them areas as well too.
And bringing this conversation full circle back to your PhD, which was funded by Rolls-Royce, how do you see batteries being used in the future of aerospace?
Oh, great question. Well, we have a number of aerospace customers, including satellites, eVTOLs, which are the flying robo taxis, if you know them, and then also in traditional aerospace, whether that's drones or eCTOL, which is like a conventional takeoff and landing. So we have a number of customers in that space, and there's a lot of investment going into it. And you might have seen yourself, the first of these sort of flying robo taxis have started taking flight in the last year. So I think there's the technology is basically proven at this point. The application, maybe not so. Exactly how they're going to be used. Is it going to be ferrying people to an airport, or is it going to be like taking people along the coast, or just within a city? That's not quite clear yet. Like where the economics of that technology lie, but technologically it is possible, and it's been proven that in the last year.
The satellites are interesting, and they're top of mind today. It was reported. So SpaceX officially filed to go public today for an IPO. So I'm staying on the satellite. It's good. They're going to raise $850 billion valuation, bigger than Saudi Aramco. But so you're looking at satellites. What are they? How is a satellite company using the Voltt database?
Yeah, it's crazy to think, but most satellites that are in space today actually use commercially available batteries, and for a very good reason. So I thought 5 years ago that any satellite application will be using some bespoke custom chemistry that's, tailored, and they've squeezed all the energy density into it as they can. But that's not true at all. They actually use commercial cells from the likes of Samsung, Panasonic, LG, etc. And they do that for a very particular reason, which is in space, you need absolute reliability. Yeah, it costs so much to put the thing into space that you need it to work for the next 5, 7, 10 years, guaranteed. And the problem with a prototype cell from a manufacturer that they've made 100 of them, and they're the world's most energy dense cells, is they're just not very reliable. You just can't be sure that's going to last 5, 10 years. Whereas a commercial cell that they make 100 million of them a year from LG or Samsung, you can be sure that is going to be super reliable. So it's actually, these satellite companies use commercial cells, which is quite surprising. And they take the hit on energy density, which might be 50, 60%, but what they get is ultimate reliability with that.
Well, they need reliability. Can your simulation platform help them increase reliability as they look to put in different cells over time?
Yeah, we build degradation models of batteries as well, which actually model how the battery performs over lifetime. They're extremely difficult to build because the data takes years to collect, and it's extremely expensive to collect years of data on a specific battery. But that's exactly what we're actually helping some of our satellite customers with, is not just the cell selection and the pack design topics, but also the degradation and lifetime modeling of them applications. And we're working with some of the most notable satellite companies that exist, including a few of the billionaire-backed satellite companies. So yeah, we've been very fortunate to be able to sign up some of the top in the game.
It's wonderful. Putting this all together, Gavin, in your opinion, what does the future of energy look like?
Oh, across the whole world. That's a big question.
Yeah. We have to go big.
Yeah. For me, I think it's about how it's going to level up society as a whole. For me, the most exciting aspect of batteries isn't necessarily the motorsport or the satellites. It's actually, for me, is about things like microgrid and bringing distributed energy to the developing world. I think that's where it's got a big part to play. Like I live in London, our office is here in central London, and EVs have been great for London in terms of air pollution and actually the benefits that's now bringing to society here in London. So that's great. But I think the bigger ones are, slowing down climate change, and also allowing things like distributed microgrids in countries like Africa or Asia, where it means people can have cheap solar panels, cheap batteries, and actually use that to produce clean water, running washing machine, etc. And the benefits that brings to society, for me, is even more exciting.
It's wonderful. I mean, the end of the day, energy makes the world go round. Energy powers the economy. Energy powers opportunity. Gavin, this has been a fascinating conversation into energy, and especially about energy. As we look to wrap up for today, what would you like our listeners to take away with them?
Yeah, I think the biggest one, especially to the engineering audience you have, is just the power of model-based design, which has been used heavily, throughout other engineering disciplines, and that's now really come into the battery industry. But it's still relatively new in the battery industry, and there's a lot of work to do. And that's the thing that we're really trying to educate and teach. So we have free educational resources, blogs. If you follow our LinkedIn, we try and put out as much free content as we can to really enable that next generation of engineers, particularly on model-based design. But I think that would be the thing for me, is just how much like simulation can actually accelerate design timelines.
I'll summarize it this way: follow about energy, learn about model-based design, and go build the future of energy. Today is tomorrow, tomorrow's today, the future is about energy. Gavin, thank you so much for coming on SAE Tomorrow Today.
Nice, it was a pleasure. Thanks very much, Chris.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week when we'll discuss how QNX is helping automakers unlock what's next in software-defined vehicles.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.